Section 6.5 is on two rules that we're going to be going over. And what this is going back to is estimating areas, or in this case, estimating integrals, using different shapes. So we've learned how to use RAM, left RAM, right RAM, midpoint RAM, which are all rectangles. But if you remember, we said we didn't have to use rectangles. We could use other shapes. So in this video, we're going to talk about what if we use trapezoids. And then later in this section, we're going to talk about what if we used parabolas. So the trapezoid rule is just saying, let's say I look at x squared again, which is what we used before with RAM, and I want to estimate the integral from 0 to 2 of x squared. In other words, what's an estimate of the area between x squared and the x-axis? And we're going to use 4 trapezoids. So if I divide it evenly from 0 to 2, each trapezoid, I'm going to have 1/2 between each trapezoid here. And if I start over on the right side, just to make it easier to see, remember the area of a trapezoid is 1/2 the height times base 1 plus base 2, or the average of the bases times the height. Now the bases are the parallel sides and the height's the distance between those. So over here between 1/2 and 2, I just draw from each point up until it hits the curve and then connect them. And here is my trapezoid. Now what I have to watch is the parallel sides are my bases. So this has a height of, that's 4, this would be 2.25, and then this would be 0.5. So the area for this trapezoid alone would be 1/2 times the height of the trapezoid, which is this 0.5, times the sum of its two bases. If I go to the next trapezoid, it'll be between 1 and 1.5. So going up, then connecting those. That's going to be 1/2 times the height of the trapezoid, which is 0.5, times the sum of the bases, so 2.25, and this would be 1. Again, continuing on, here would be my next trapezoid. So its area would be 1/2 height of the trapezoid, and then the bases would be 1 and 0.25. And then finally, my last trapezoid, and I know I'm calling it a trapezoid even though it doesn't look like one. The weird thing is that one of the heights, one of the bases is 0. So it is a triangle, but if we consider one base being 0, we can say this is a trapezoid. And then if I go ahead and multiply all this up and add it up, I'm saying that the integral from 0 to 2 of x squared using trapezoids is about 2.75. Now, one of the things we can do with trapezoids is we can talk about overestimating or underestimating. And the way we look at this is we look at concavity. If between our limits of integration we are concave down, I'm sorry, concave up, my fault. If it's concave up, we're going to be overestimating. And we can actually see it here in that little bits of our trapezoid are above the curve. So we have too much area. Whereas if I am concave down, we're going to be underestimating because our trapezoids will fall underneath the curve and we won't get quite all the area that we need. So for example here, if I look at x squared, if they're asking me if trapezoids will overestimate, without actually doing this, all I need is concavity, which requires my second derivative. So my first derivative would be 2x. The second derivative is 2. Well, this is positive, so we're concave up, and concave up means we are overestimating. For another example here, if we look at negative 1 over x, well, again, without actually doing trapezoid rule, if I look at concavity, I can decide if it'll be an over or underestimate. Well, the first derivative would be 1 over x squared. My second derivative would be negative 2 over x cubed. Well, because x is between 1 and 3, I know x cubed is going to be positive, while negative 2 divided by positive is going to be negative. So this is concave down, which means we are underestimating.